Good day, good day, good day. How are you doing? Um, it's quite a beautiful Monday, and it's quite cold this side. How are you all doing? So today it's another edition. Today it's another session which we have. We meet so that we can prepare each other for our trial exams. Others they call them preliminary exams, others they say preparatory exams. So today we'll be looking at financial maths. So it's your first time to tune into the channel, please do subscribe, like the page, comment, leave your comments there. And also in the description of this YouTube video, you'll definitely find the link which you can use to call us on Zoom, or you can actually join our WhatsApp group where we can provide you the materials. And maybe if you have a quick problem at 9 o'clock p.m. at night, you can actually text us, then we can actually try to assist you and make you something so that you can definitely understand the concept. Bear in mind that we are preparing grade 12 trial exams. The exams are around the corner. It's now like 90 days left before you start your trial exams, if I'm not mistaken. And one of the topics which is a bit challenging, whilst easy at the same time, is financial maths, which is done on term 3, which is like the basic from grade 10 to grade 12. So I'm gonna just do an overview on financial maths from grade 10, then we come to grade 12 and we explain further. Then we can do the trial exam from Gauteng Department of Education for 2021, which is last year. So let's get down to the business of the day. So today we'll be doing financial maths, as I've said and as I've outlined that. So what is important on financial maths is to understand the concept which we live on our day-to-day lives. For instance, understanding few basic things like interest, understanding higher purchase, understanding the basic things which you're actually applying on our day-to-day life. For instance, we have things like depreciation, we have things like inflation. So those things are the basic or are the building blocks of financial maths. So on my overview, I want to start on grade 10. So on grade 10, what were we taught on grade 10? So we were taught, and to summarize, we were taught how to use simple and compound growth formulae. Okay, great. So we're taught in grade 10 how to use the compound and the simple growth formulae. So for instance, these formulas are only two. The first one is A is equal to P1 plus IN, and we also have A is equal to P1 plus IN to the power N. So these are the two formulas which were taught in grade 10. I'm going to explain them further. Then we go to grade 11. So on grade 11 now, coming back to grade 10, two formulas. So these two formulae is where now when we are given problems in the exam, they will definitely look at these few things. For instance, they will be looking at interest, they'll also be looking at high purchase, they'll also be looking for inflation, they'll be always looking for population growth, and sometimes other real life problems which we actually face on day-to-day lives. Then also now in grade 12, grade 11, we were also told about this simple and compound growth formulae. But now in grade 11, now we are branching to different things, that now we are looking at problems which include straight line depreciation. So depreciation is when the thing which you have loses its original value. For instance, when you buy a new car today, then after the moment you drive it out of the warehouse of the car or the company of the car, it has already depreciated. If you think you're gonna return it and say, let me have my original amount of money, you won't get it because it has depreciated. So those basic things, those real life things, is what we are applying here on financial maths. So also on the grade 11 work, we were also told about the depreciation on a reducing balance. Then also the effect of different periods of on compounding growth and decay, which include the effective and the nominal interest rate. For instance, they will tell you that it has been compounded yearly, it has been compounded quarterly. So that would definitely tell you that the value of n must be divided by 4, must be divided by 2, must be divided by 1, depending on which effective which part, or which quarterly, or sometimes they'll say quarterly, sorry. So sometimes they'll say quarterly, sometimes they'll say monthly, as I have said before. So you must be able to underline those basic terms, which is so important that you apply, because the moment you forget when you're using a compound formula to apply the fact or the problem solving methodology of using those quarterly things, like dividing the value of n by 4, dividing your value of n by 2, then you'll be penalized, and sometimes you don't even get an answer. Then now in grade 12, you have been taught about these two formulas now, building from grade 10 and grade 11. So in grade 11 and grade 10, they were building to your grade 12 stuff, that now you now have to apply the knowledge of geometric series to solve the annuity and the bond repayment problems. So this is now a bit different now, because now you must be able to critically analyze different loan options. So now we are applying this same concept now on our financial man. So that was a small interesting thing which I wanted to talk about. So now let me just dwell more on my my formulas, or let me just say recap, or let me just say revision. So let's say recap, okay, or recall. So on my recall now, I want us to have this formula. So 1.1, we have the formula for simple growth. We have the formula for simple growth formula, which is A is equal to P1 plus IN. What is our A? A is the accumulated amount, this is the accumulated amount. This is the P is representing the principal amount. Which is the amount which you have borrowed, or the money which you have invested into. Then I is the interest, rate. It's the interest rate, which is always in percentage. Then N is the number, or let's just say it's the time. Say it's time interval. It's the time interval which is given always in years. Okay, now moving on 1.2, we have the compound growth formula. So the compound growth formula is the one which says A is equal to P1 plus I to the power n. So these formulas, all of them, they are the same. The algebraic letters A, P, and N and I, they still represent the same. A is still representing the accumulated amount after a certain period of years. I is representing the interest rate. Then N is representing the time, which is usually in years. Okay, great. Now we say that the depreciation is the loss in value of an asset caused by maybe being used, or being having been used for quite a while, and also by the age of the value which you have bought. Then now on 1.3, now we have what we call the straight line depreciation. Depreciation. Sorry. So straight line depreciation is now the formula A is equal to P1 minus IN. Okay. That is the straight line depreciation. Now we are subtracting now. Bear in mind that this formula and this formula are different. The simple growth formula, we use plus IN, but now the straight line depreciation, we are subtracting. Why are we subtracting? Because now we say that what you have bought now, it has now been reduced in its value. Okay, great. Now we have the straight line depreciation now 1.4. Well, let me just say this is my A and this is my B. Then we have the reducing balance depreciation. So now we are using the reducing balance method. So when you're using the reducing balance method, A is now equal to P1 minus I all to the power n. So actually, they are the inverse of the above. The compound growth formula is the inverse of the reducing balance depreciation. So those are the basic formulas which I wanted to highlight as well. So this formula, which means if this is for depreciation, which automatically means that these two are for inflation. So those two, they correspond to each other. So inflation is actually the continuous rise in the price of a basic of all the basic things. So for instance, the increase in the amount of cooking oil, that is inflation, because initially maybe it was 42 rands, now it's now 100 and something rands. So those are our day-to-day life which are actual experience. So we are applying the financial method so that you can be educated about those small things. So then we have those key terms which include like the book value. Sometimes they'll give you the terms like book value in the problem. So you must be able to understand what does the book value mean. So book value is actually the value of an asset after depreciation. So the book value is the value of the asset after depreciation is okay. So for instance, they'll tell you that calculate the book value of this vehicle after 3 years. So you must know that book value is saying that you must have the amount after depreciation has occurred. Then we have also the scrap value. So the scrap value now is the value of an asset at the end of its useful life. So for instance, after its lifespan, after its life existence, those are the things which you have to look at, that you might be given those basic terms like scrap value. Then we also have the sinking fund, which is a fund which you see up to replace an asset when it is no longer useful. Then now, as we are concluding on this part from grade 11, we have what we called, as I highlighted earlier, that we have what we call the nominal and the effective interest. We have the nominal and the effective interest. So on this formula, there's only one formula for this. 1 plus I effective is equal to 1 plus I norm over M, all multiplied by M. So this is the formula for nominal and effective interest. So now let's describe these things. So EFF, which is I effective. Let me just say where I effective is illustrated by small letter I with the subscript EFF. Wow, EFF. Then which is the effective interest rate. Then we have I norm, which is the nominal interest rate. Then we have M there. M is the number of compoundings. Wow. Compoundings in 1 year. Great. So now, as we said that we have the growth formula and the reducing formula according to depreciation, let me just write it again, which is A is equal to P1 plus 1 plus I all to the power n. So how do we calculate the value of n in this instance? Now we will apply logarithm. So that is what is important, that in order for you to calculate that n, you must use the concept which you have been taught, or which I also highlighted when I was doing function of logs. So you apply log so that you can get your value of n, because bear in mind when you're solving here, it's gonna be, is this right? So it's gonna be A over P is equal to 1 plus I all to the power n. Then when we apply log, it's gonna be log of 1 plus I of A over P equal to n. So we are applying the log so that we can actually calculate the number of years. N is representing the number of years, or we can just say it's the time interval. So great. Now going deep now to what is so crucial, which is the grade 12 part. So in grade 12, we were taught, or we are going to be taught about the first thing, which is called annuities. Okay, great. So in grade 12, we taught about annuities. So what is an annuity? So annuity is something which refers to a number of equal payments made to a regular time intervals and subject to a rate of interest over a period of time. So that's an annuity, and there are examples of annuity. For instance, regular deposits into a savings account. Those regular deposits which you do to your own account, those are annuities. And also those monthly home loan payments. For instance, if you have a loan which you're supposed to pay, which you have maybe borrowed from a bank, those 350 which you pay each and every month to the bank, those are also annuities. So now, these annuities are divided into two subsections. The first one is called the future values annuity, and the other one is the present. So this one, let me start. The first one is the future value annuity. As you can hear this, future, not now, but future. Okay, so on the future now, what is important is to understand few things, that the capital is the money which is accumulated by means of regular payments, equal payments into savings account. Underlying that basic term, that equal. So you are supposed to pay regular payments which are equal. So for instance, if you're supposed to pay 350, you must always pay 350 each and every month. They are all divided equally and paid equally from all the time. So on the future value annuity, we know that this capital is accumulated by means of regular equal payments into a savings account, which is definitely compounded with compound interest paid on the money. So what is the formula for the future value annuity? So the formula of this is F is equal to x 1 plus I all to the power n, okay, minus 1 all divided by I. Okay, great. So someone will ask me, what is this? This is the formula for future value annuity. So what is x representing in this formula? So let's start by F. So x here is representing the monthly amount which you are supposed to pay. Then I, as always, is the monthly interest rate. Then what do we have again? We have N, which is the number of payments made. It's now a bit different from grade 11 stuff, because now N is no longer representing the times. It's now representing the number of payments are made. Then we also have our formula as this. So F is representing the future accumulated amount, the future value annuity, and X is representing the monthly amount which you pay each and every month. Then I is the monthly interest rate. So actually, you can actually solve this using what we call the geometric series, which we actually did, and you can actually be able to prove this formula, but there's no need for you to know how to prove it because it's not examinable. So what is important is to understand the formula, and you don't have to cram the formula, because on the formula sheet you are granted that formula. So you must be able to use the formula to substitute the correct values to get the correct answer. You use your formula sheet and you use that same formula which is here. So you don't have to cram it and know it by head. You just have to know how to use the formula. Okay, great. So now this, as I was defining the future annuity, so we can write what we call the number line. So we are saying on a number line now, because in order for you to solve these kind of problems, these financial maths, you must be able to have the conceptualizing concept and conceptualizing mindset, in a sense that if you draw your timeline, This is the timeline in the form of a number line. So it will actually assist you to know that, okay, this amount was paid T0 initially, that you borrowed, you invested your money, or you borrowed your money on this specific day. That's the day you started to do this thing. For instance, you bought your car or something. So that car which you bought now, maybe you did a deposit with an immediate effect, that from day one which you took the car, you already made your first monthly installment. So you must be able to write your timeline so that you can actually be able to clarify and have a bit of clarity and understanding the concept better. So according to the annuality, the future value annuity, so we have T0, then we have our T1, then we have our T2, then we have our T3, which is X. These are the monthly amounts. Then we have our T n minus 3 as always, then which is X, then T n minus 1, which is X, and T. We know that X is the value which we pay each month. So now in this timeline, we are assuming that the payment is made at the end of the month after the account is opened. So you open an account this month, so the first payment which you pay after the month has ended, it will have this specific timeline which you are seeing right now. So in other words, that's why you're seeing here on T0, there is nothing on T0. Why is it that there's nothing here? It's because you pay your amount of money at the end of the month. Okay, great. So now moving forward from that, we have the basic things which are so important. That, so to recap again on this formula, why am I recapping? Because this formula is so crucial. Bear in mind that in your exam, financial maths is 15 plus or minus marks. So now, great. So now F is there. We said it's the future value, which is the amount intended to accumulate, and X is the monthly amount which you pay each and every month. Your I is your monthly interest rate or the periodic interest rate. Then N is the total number of payments during the investment period. But now we have the special cases which are so important for you to realize. Okay, so we have what I call special cases under this future value annuity. So the first special case is that if the first payment is made immediately and subsequent payments are following after you have already paid the first one, or after you have made at the end of the month, then now you will be able to see that it will have n plus 1 payments. So now we are saying that if your timeline is looking like this, so you do what you do, you take you made the payment immediately. So when you make the payment immediately, so it will be like T0 is already X, then T1 will be X, T2 will be X, until we reach to Tn minus 2, which is also X, Tn minus 1, which is X, and Tn, which will be. So your timeline will be like this. Now, case number 2 now. This is when now payments are made at the beginning of every month. Then now it means that the last payment is made 1 month before the end of the investment. So now your timeline now will be different. So these two are so important that you understand that there are two special cases. The first one is now when you pay immediately, then the other one is when the payments are made at the beginning of each month. So when you make your payments at the beginning of each month, that will definitely mean that after during the investment, the last month which you're supposed to pay, it's already cleared because you are paying at each and every beginning of the month. So now you must understand that now this timeline is still the same, but the formula will be a bit different. Now F now is now equal to X 1 plus I all to the power n minus 1. Then we divide everything by your I again. Then we multiply by 1 plus I. Okay, so this is the new formula. So you must be able to understand and read and understand the question. That the question is highlighting that, okay, this person is paying his or her monthly amounts each and every beginning of the month. So this is now the formula which you use. You can't use that formula which we have here because now it doesn't have this multiplication of 1 plus I. Then that was our future value annuity. Now let's look at the present Let's look at the present value annuity. The present value annuity. So on the present value annuity now, which is the present, this one is now the regular equal payments that are made in order to pay back a loan. So now these payments include the interest that has accumulated on the loan used for. So for instance, now on the present value annuity, now for instance, there are these few things that you are now having regular equal payments made in order to pay your bank loan. So these are your loan repayments. You are repaying the loan. You are also having those bond repayments. The bond, we all know that the bond is for people maybe who took houses and stuff like that. So those are the payments. So these are present value annuity. So what is the formula for present value annuity? It is illustrated by P equal to, again, it's still X, but now it's now 1 minus 1 plus I, all to the power negative N, okay, all divided by I, where P is, let me write it again. So where P is, what is P? P is the loan amount. Then what is your X? X is still the same, it's the monthly payment. Then what is your I? Your I is still the interest. And what is your N? Your N is the number of payments. Your N is the number of payments. Now, great. After this present, there is something which is important, that what we call, or a subheading which is so important, which is called the outstanding balance on a loan. How will you be able to determine the outstanding balance on your loan? So the outstanding balance on your loan now is now the balance left to complete paying a loan after a number of payments have already been made. So now the balance is the money actually which is left after you've already started paying your repaying the bank, repaying. So that balance is also calculated. So how do you calculate the balance? So the balance is equal to X 1 minus 1 plus I to the power negative N, all divided by I, where now N is equal to, let me use a different pen, okay. So when N is equal to the number of payments left, okay, to complete the loan. So N now is now different. N is now representing the number of payments left to complete the loan. So for instance, if initially your N was maybe 100, now maybe your number of payments which is left for you to complete the loan, maybe it's like maybe 20 or 15 or 10. So it is so important to understand that this is how you calculate your balance. The balance is still the same as the present value annuity formula, but the change is that now the value of N now is no longer like initially that it was the number of payments, but now it is the number of payments which is left. And also instead of writing P, now you're writing balance. Then also now what is important is to understand that this balance formula can also be written in a different way, okay. So you can actually say or, so there are actually two formulas to write to determine the balance, or you can say that balance is equal to P 1 plus I to the power N minus X 1 plus I to the power N minus 1, okay, all divided by I. So now you are using your compound growth formula and you subtract the future amount. Then after that you can get your balance. Still, the value of N now is still the number of payments now already made. So now you see that's the difference. So you can actually use the above formula or you can use the below formula. So now the n now is now representing the number of payments which you have already paid. Why? Because now we are subtracting the future value annuity from the compound growth formulae. Okay, so now note that the balance left to complete paying a loan does not include the interest. Always know that the balance which is left doesn't include the interest. Okay, great. So those are the formulas and the recap or the small overview which I had for you guys. So bear in mind that these formulas which I gave you, they are so important. These grade 12 formulas, they are so important. Why are they important? Is that because they are important because you must be able to apply them carefully and listen to the question and analyze the question before you do anything on the question. Okay, now let's look at the examples. So as you can see now, we are looking at Gauteng Department of Education Preparatory Exam 2021, paper 1. So solving for X, those things, you're good at them. So today, let's go. Here we are. So as I was saying, it's plus or minus 15 marks. You can see that this is 1 plus 3, 4, plus 5, 9. 9 plus 1, 10, plus that 4, that's 14. So in this case, there are actually 14 marks. So now, this is the question which we are doing today. All right. What does question 1 want? So Janet invests a lump sum of 5,000 Rand into a savings account for exactly 2 years. Okay. The investment earns interest at 10% per annum, compounded quarterly. So now, before we even go to the question, there are a few things which we must highlight. Janet invests. So he is not borrowing, he is investing. You underline. Okay. What did he invest? He invests 5,000 rands. Okay. Which means that amount is the principal amount. We are analyzing our question. So he invests 5,000 rand. So the money which is invested or the money which is borrowed, we say that initially when we're doing an overview, we say that that's the principal amount. Then into a savings account for exactly 2 years. Now, 2 years is the time interval. Okay, great. Now, it has been compounded quarterly at a rate of 10% per annum. Now, you must underline that part, that compounded quarterly, which means the interest rate has been compounded quarterly, which means it's 10% divided by 4. That's the first thing which you must know. Quarter, it's 1/4. So every year has 12 months. So those months now, when we're saying a quarter, we are actually saying it's like 3 months. Okay. So it has been compounded quarterly. So you must know that the value of n is going to be divided by 4. Great. Now on question 6.1.1. What is the quarterly interest rate of Janet's investment? That's 1 mark. To determine the quarterly interest rate of Janet's investment. Janet's investment. So now let's determine it. Great. You can see actually that it is 1 mark, which means there's no much work you're supposed to do. You just have to do something which is so easy. So what is the interest rate? So the interest rate here is just going to be the 10% divided by 4. 10% divided by 4, which is like 2.5%. So again, what was the question saying? It was saying that what is the quarterly interest rate of Janet's investment? So Janet's investment was compounded quarterly, so you must divide that 10% by 4, then you get your 1 mark. Okay, great. Now, question 6.1.2. So on 6.1.2, calculate the amount in Janet's savings account at the end of 2 years. What is the amount that Janet has after 2 years? So now this is not that hard. Why is it not hard? Because we know and we understand the fact that, okay, this amount that Janet invested was compounded quarterly. So the fact that it's compounded quarterly, which means we're going to use the compound growth formula. What does the compound growth formula say? A is equal to P1 plus I all to the power n. What is P? P is the money which is invested, is the principal amount. I is the interest rate. N is your number of years. So now, let's do this. So, P is 5,000 rands. 1 plus, what is our I? Our I is 0.1 divided by 4. You still remember when we were talking about the nominal and the effective interest rate? We say that 1 plus I effective is equal to 1 plus I nominal divided by M, where that M was representing the compounded annually, compounded quarterly, compounded semi halfly or something like that. Great. So now what is important is to understand that, okay, now my I, which was 10%, is now divided by 4. 10%, we know that 10% is the same as 0.1. So 0.1 divided by 4. Then what is our N? Our N is 2 years. Then we multiply by 4 because it has been compounded quarterly. Then we use our calculator after that. Then our value of A now, in this case, now it will be 6,092.01. So just to recap again on this amount, you know that money has always supposed to have 2 decimal places. You can't have your money which has 5 decimal places. Money has cents. So please don't do that mistake again. Right. Now on 6.2. Oh, okay. 6.2. Sihle inherits 800,000. He invests his entire inheritance in a fund which earns interest rate of 14% per annum, compounded monthly. Underline that. Compounded monthly, which means you're going to divide the interest by 12, monthly by 12. Okay. At the end of each month, Sihle withdraws 10,000 from the fund. His first withdrawal is exactly 1 month after his initial investment. So now, how many withdrawals of 10,000 will Sihle be able to make for his fund? How many withdrawals will Sihle be able to make for his fund? Okay, great. So now, let's look at this and analyze together. So they're saying that Sihle inherits 800,000. He invests his entire inheritance in a fund which earns interest at a rate of 14% per annum, compounded monthly. At the end of each month, Sihle withdraws 10,000 from the fund. So in order for us to determine the right formula for this question, we must understand that there is a part which says he withdraws the amount of money. So the moment you see that part that says withdraws, which means in your mind you must know that you must use the present value equation, which says that x, p is equal to x, 1 minus 1 plus I to the power negative n, all divided by I. Great. Now, what is our P? Our P is the present value which he invested, which is 800,000. What is X? Each month, Sihle is withdrawing how much? 10,000. So that will be our monthly amount, which is 10,000 rands. Then now we have 1 minus 1 plus. What is our I? Our I is 14%. And we know that 14% is the same as 14 divided by 100, which is 0.14. So now it's 0.14. It has been compounded per annum, monthly. So now it's going to be divided by 12 because of that monthly, then to the power negative n, because we are calculating how many withdrawals Sihle will be able to make after he withdraws 10,000 each and every month. Then what is our I? Our I is 0.14 divided by 12. Then after that, now we are now solving. Okay, so how can we solve this? So we can actually say that 10,000, we divide both sides by 10,000, then that will be 80. Then you multiply 80 times 0, or that times this. So let me just show this. So it's gonna be 10,000. Then you divide both sides by 10,000. Divide both sides by 10,000. Divide both sides by 10,000. You can actually see that this and this will cancel. Then we are left with 80. Then this 80 is now multiplied. Now we are doing our cross multiplying. We multiply. Then we are left now with 1 minus 1 plus 0.14 divided by 12, all to the power negative n. Then now we multiply this. So when we multiply this, my calculator is giving me 0.67. Okay, then now so now before we have this 0.67, we must transpose so that we are only left with the one which we want. So when you transpose this to this side, so it's gonna be 1 plus 0.14 over 12 to the power negative n equal to 1 minus 80 multiplied by 0.14 divided by 12. Then now it's gonna be 1 plus 0.14 over 12 to the power negative n. Then this is now, when you use your calculator, then that will be 0.67. Okay, let me just recap something fast because my screen was not showing well. So now, as I said, that since he's withdrawing the amount of money, we use the value P. So we use the formula of present value annuity, which is P is equal to X open bracket 1 minus 1 plus I to the power negative n over I. Then now what was our P? P was the amount which he invested, which was 800,000, and each and every month he is withdrawing 10,000. So that 10,000 which he is withdrawing is now our value of X. Then we know that it has been compounded monthly. So you divide the interest rate by 12, then divide by 12. Then after that, now we are trying to solve now. So here we are now. Now let's now use what we call our logarithm. Okay. So when we use our logarithm now, we know that we have negative n. Let's just use the log from, it's going to be negative n is equal to log of 1 plus 0.14 over 12. Then here we have our 0.67. Okay, then after that we need positive n, so we divide by negative 1, because this is going to be negative as well. So our value of n is 233,469. But now, due to that comma, we must now conceptualize and understand that the value of n now is going to be 233. So he's going to withdraw his amount. So Sihle will make 233 withdrawals of 10,000. Okay, so he will make those withdrawals for 200 and you will make 233 withdrawals. Now 6.2.2a. Okay, 6.2a. Exactly 4 years after his initial deposit, Sihle decides to withdraw all the remaining money from his account to use a deposit towards a house. What is the value of Sihle's deposit to the closest rent? Underline that. So that's how you are supposed to understand that. So you must do it to the closest rent. So now we must first calculate the accumulated amount using the compound growth formula so that you have the accumulated amount. Then now we can use our future amount. Okay, great. So now the first thing we say that what are we going to do first? So we're going to calculate the amount which is accumulated. So 6.2.2a. Let's calculate the amount which is accumulated by using our compound growth equation. So what is our P? Our P is how much? It's 800. Let me see. Okay, it's 800,000. Okay, so it's 800,000. Then it's 1 plus 0.14 all divided by 12. Then now he's gonna take his month after 4 months, after 4 years. So it's gonna be 4 times 12, which is like 48. Then let's use our calculator. Then we use our calculator. 800 times 800,000, open bracket, 1 plus 0.14 divided by 12 all to the power 48. Then you use your calculator. Then you're gonna get 1,396 and 5,54. So this is the accumulated amount at 4 years. Now let's calculate the future value now. So the future value, f is equal to x 1 plus I to the power n minus 1 or divided by I. What was our I? Sihle was withdrawing each and every month 10,000. So it's gonna be x 10,000, then 1 plus 0.14 divided by 12. Then now what is our n? Our n is still 48, which is 4 times 12, because it has been compounded monthly, and also it's after 4 years. Okay, then minus 1, then we divide again by our 0.14 divided by 12. So the future amount, when we use our calculator now, it's gonna be 638,577.36. Okay, you see that it's a 5-mark question. Oh, it's a 4-mark question. You're not yet done, because we want to know, as the question says, we want to know what is the value of Sihle's deposit to the closest rand. So what do we do now? Now we just have to calculate the remaining amount. So the remaining amount which Sihle will have will be, you can write here, remaining money is equal to accumulated amount, or the total amount which you calculated by using the growth formula, minus the future amount which you have calculated using the future value annuity. So it's gonna be 1,396 and 5,54 minus 638,577,36. Then your answer after this will be 757,428 757,428.18 cents. So this is the amount which is needed. This is the amount which is needed. Then let's do the last question of the day. So the last question is the one which is saying B. Sihle's deposit is exactly 30% of the purchase price of the house. What is the purchase price of the house to the nearest rand? That's easy now. So now that's so easy. So they only now need the purchase price of the house to the nearest rand. Now we know that what was the purchase price initially? We know that we calculated initially that, okay, the value of Sihle's deposit to the closest rand is 757,428.18 cents. That amount now is the value of the amount Sihle has after 4 years. Then now we must just calculate the 30%. So you're gonna say 30% times x is equal to 757,428.18. Okay, then now what will be our x? Our x now is just gonna be 757,428.18 divided by 30%. Then you use your calculator, then your answer will be to the nearest rand. So it's gonna be 2,524,760. So that will be the answer for that problem. Okay, that will be the answer to that problem. So we say 30% times x is equal to the amount which you calculated before. Then now we calculate the value of x by dividing by 30%. Then our answer was 2,524,760 to the nearest rand. So that is what I have had for you guys today. Please make sure that you go through the overview which I gave you. It's so crucial, it's so important. It will enable you to calculate each and every problem which you can definitely encounter along the way. All the best. Continue preparing. No pain, no gain. So prepare as much as you can for your trial exams. Wish you all the best. If you have many questions, don't forget to drop your comment and ask us on our WhatsApp group so that we can proceed and we can assist each other. Till then, have a blessed day ahead.